So again, thank you for joining the webinar. I'm going to talk to you about the data-driven smarter manufacturing, which is the first of the webinars during this year that Quva will be organizing. The second one will be in Q2. I'll talk about that at the end of the presentation. So here is me, just shortly about me. I'm one of the founders in Quva and Vice President of Sales and Marketing. My background is in development of industrial services, and I'm also the member of the board in Finnish Maintenance Society ProMaint. But what is more important is what our company is doing, because that's kind of the background why we are giving this webinar series. I'll tell about that just shortly. But the agenda for today is to have a look at these four things. AI for a manufacturing company, what does it mean for them? Data utilization as a key to success. What kind of approaches can you take in there? Then making manufacturing smarter. What kind of cases could you do through which data utilization could be better and therefore the manufacturing itself smarter? Lastly, we will talk about the lessons learned on how to ensure success in data utilization. So that's the agenda, and about 40 minutes the webinar will last. Just briefly about the company itself. We are an AI software company focusing on the manufacturing excellence. We have done over 150 projects related to data utilization or analytics, big data, AI, etc. Lately, we have focused a lot on the pulp and paper industry, as that industry is quite, they have a lot of data, collecting a lot of data from their operations, have huge energy and efficiency needs, and also they want to do things right the first time. So in a way, that kind of companies, which are also in other industries, are very much a fruitful environment for our expertise and services. But that's kind of the background, as we have done for many years these kind of projects and offered products and services there. That's the background why we are talking about these themes that today and later webinar series. So first, let's go to the AI for a manufacturing company. I've added 3 polls to this webinar as well to keep it a bit interactive. So later I will let you know when there will be polls that you could participate with. And also feel free to write any questions or comments to the chat, and I'll address them at the end of the webinar, the latest. So when talking about this hype terminology like big data, Internet of Things, artificial intelligence, this is one of the pictures that might come in mind to some people from the manufacturing industry in general, is that the emperor has no clothes, the old story of that. And the idea is that these things, these hype words, are something that there's nothing new under the sun. For example, pulp and paper industry have collected data. They have had sensors, they have had visualizations and automation in many things for decades already. And now someone, or actually many companies, are coming to them telling that, hey, there's this new AI or IoT, and this would solve all your problems. And so it is quite easy to understand that some people see this as more like some kind of a fraud, even that, or at least something that people from IT companies, for example, when they are contacting pulp and paper companies, it feels like that they might not really understand the environment where the pulp and paper companies are, or other process manufacturing companies. But how we see it is that definitely there's too much hype with AI and these other terms, but what has changed is that all these different technologies currently form a more sound entity than in the past, which leads us to be able to better utilize all technologies in a more seamless fashion, which leads into advancements in the actual process and products as well, and kind of improving the mill operations. But let's talk more about that soon. Coming back to the hype terminology, there are many different definitions for different things, like AI. In Wikipedia, it was said systems' ability to interpret and learn from data and achieve specific goals and tasks. Then for big data, there's a different definition of if the data is big, it has to have certain volume, velocity, variety, veracity. Then IoT is about sensors, data transmission, storage, data analytics. And then Industry 4.0 is a combination of IoT, cloud, and AI. And then there's a multiple other terms as well, from digitalization to industrial internet, etc. But what needs to be understood is that what is essential about this? It's not about defining whether what you are doing is whether it is under the AI or big data. What is essential is that all these terms are related to the fact that valuable data for business is being collected all the time in the mills and plants or factories, but it is not utilized to its full potential. And that's the key, and that we will be talking about in this webinar as well. So here is the typical status of data utilization in many mills. And it is leading into waste. So there are several different data sources. There are several different tools that some people know how to use, some people don't, and some people are better in using Excel, have their own templates, and others maybe use only the equations with pluses and minuses. And then there are several roles in a traditional mill that need information for decision support. They need information in the right format at the right time, the right place. And that's the key problem in many mills at the moment, that you don't get the information at the right time in the right format. And that leads into waste, which can be seen as quality problems, efficiency problems, even problems with the security, etc. So that is something that needs to be solved, how to have seamless information flow from the sensors, from different data sources, regardless in which silo they are at the moment, to be refined into the form which is easily approachable for the end users. And they don't need to be data scientists, as many of us in Quva are, in order to utilize that information. So this is the typical problem and what needs to be then solved. Now, again, to the data utilization as a key to success. How to approach this? The first thing to do is defining what is your business problem. These are some of the common business problems that we have encountered and started solving with our customers. Too much time spent in troubleshooting, too much variation in the process or in the end quality of the products, too little relevant information sharing, too low production efficiency, too many quality claims, and too many quality defects in finished products. These are the typical ones, but point is that you first need to start there instead of starting in a way that you say that, hey, now we want to install this AI to our mill, because first you need to have the problem that you're trying to solve, and then it is a lot easier to define what kind of technologies, whether it is AI or something else, that will solve that. Well, quite self-evident anyways. I will now publish this poll. Let's try how it's working. I think you should be able to see now the question on what is your biggest business problem in in what you are doing at the moment, and there are these 6 options, and one is also the other one, and I will then publish the poll results soon. But anyways, you start with the problem. What is your business problem? And then move forward. The second thing, or actually, let's first discuss how we have done this in Quva. The key problem, customer problem that we are solving with our product is too much variation in the process. And what kind of effects does that have into the mill operations? The implications are that when you have too much variation in the process, then you have too many quality defects and related waste, too many quality claims and related costs, too much raw material consumption, and too much energy consumption. But why is it that this has not been solved in the past? The data is scattered, as we just saw in the previous slides. There are too complex tools at the moment, the traditional tools in the mills, that need to be utilized by mill personnel in order to get the right understanding on where the variation is coming from and when is it coming from. Also, as many mills have scarce resources, human resources, there is usually no time to identify root causes. And then there's, it is even more problematic when the mill has a high number of products and grades. The variation is even higher. Now let's have a look at the results of this poll. So it's good that I picked this Quva's the customer problem that we in Quva are solving, as that was like 53% of the replies to the poll said that the biggest business problem is too much variation in the process. The second one was too much time spent in troubleshooting, which is very common for us as well. We'll be tackling that later in the slides. And the third one, with 13%, is too little relevant information sharing between mill personnel. All right, thank you for your answers, and I wait for the next one. Then, when you have defined your business problem, then moving on to who then are the people in the mill who will utilize the data and the information. These are the typical roles that we have encountered: a process engineer or a quality engineer, mill management, operators, and then IT or automation experts. Those are the usual roles that need timely information. And the information for an operator is usually something, or I would say useful information for an operator is something that is different from a useful information for a process engineer. And that's something that really needs to be taken care of in solutions for data utilization. So you need to understand, after the business problem, is that who then are the actual users. And when you are implementing a system that will help you do things better to solve the business problem, you need to keep in mind that you should have those people who then will be the actual users. They should participate in designing the solution, how to configure that, and so on. If they are not, then you will most probably end up to the one of the biggest nightmares that we have seen and heard from the mill personnel, that they are buying a solution that no one is using, and it is kind of standing there with one screen showing something and no one is looking at it, and that's something that you don't want to do. Okay, so after you have defined the business problem, defined who are the users, then you would move on to defining the user stories. What exactly a process engineer would do with the information, etc., etc. But now let's have a look here on the 5 different approaches on how to utilize data in a mill or a plant or anywhere else. These are kind of 5 general approaches, but all of these are relevant in a mill. The first one is the predictions, and that is quite self-evident. If you can tell what will be happening in the future, you most probably can do things to kind of do things the way you want in terms of the prediction. For example, predicting failures in the process or end quality measurements based on the process data, etc., etc. And this is the area where most media coverage is talking about in terms of AI or big data analytics. Then the second approach on data utilization is the big picture. Now imagine a pulp mill which has several different departments. All of those departments have a lot of data. Usually all of those departments are looking only to the data their department has, and they are trying to optimize things with that data in that department. And all departments are doing the same thing. But in the end, if different departments are only optimizing their own operations, you might end up in suboptimal operations of the whole mill. And with data utilization, better understanding on what's going on, how things are interconnected, you could have this kind of a big picture view on how things should be run in the first place, taking into account all departments. The third approach is the automation. As there has been a lot of automation in the past in automating some physical tasks during the last century, for example, that has changed a lot how mills look like today, and significant efficiency gains have been received. But when talking about data utilization and data analytics, it's pretty much the same thing, except now it's not that physical tasks anymore, as the tasks that are now being automated are things like combining data from different data sources, pre-processing of data, selecting interesting variables from one data source and the other, comparing those, identifying things from that data. Imagine that all this would be automated. How much time and energy would be left to do things, to do actions based on those refined information? And that's something that is kind of the next phase of automation in many mills with the use of AI and data analytics. Then the fourth one is the recommendations. Now imagine that you are visiting an online shop of books, and you're looking at one book and then you get recommendations of other books. Now what is done there in the background is comparing how you are behaving in that shop to previous thousands of visits of other people, what they have been looking at, what kind of books, what they have been interested about, what have they bought. Now imagine this setting but put in a mill environment. and then imagine that you're a maintenance engineer, for example, and the information that you would get is based on what you might be interested. The analytics is identifying things from all of the data in the mill that you as a maintenance engineer might be interested, and those will be given to you directly to your monitor. This is helping mills to perform better, to identify things faster, and be more efficient. Then the fifth one is I call it from tacit knowledge to explicit knowledge. There's a lot of tacit knowledge in mills that are only in the minds of different operators, engineers, managers, etc. The problem comes when this particular engineer that knows everything is not on a shift when problems occur. And then the mill might have significant losses just because there is not that information in the house at the moment when it's most needed. Now, data analytics and data utilization, one of the approaches is to get that tacit knowledge in many different forms inside to the analytics system, so that the mill would not be dependent on who are the actual people working in the mill at any given time when problems occur, for example. So these are the five general approaches on data utilization that we have encountered and worked a lot with our customers. Again, I put a new poll to this webinar asking you about which of the approaches to data utilization would your mill or plant or company benefit most. And feel free to answer that, and let's have a look at the results soon. Then, moving on to making manufacturing smarter. What are the kind of actual use cases or use case concepts that we have encountered that might be beneficial to you and your company as well? The first one is the quality assurance. The current state of quality assurance in many mills is that when you're producing something, some products, in this case reels, there is the end quality measurements which are taken on a sample basis of some of the products that were manufactured, checking whether some variables in those some of the products are okay, and if are, then all the products are sent to the end customers. The problem is that this kind of sampling quality assurance might not always identify the problems that there are in the finished products, and then you might end up having quality claims which might be very expensive. Now, the new way of doing things is not only utilizing the lab end quality measurements, but also utilizing all other data that is coming from the process already during the production. As there is a lot of process automation data, there might be maintenance data, raw material data, and online quality measurements as well. And again, at the end, the end quality measurements in the laboratory. When all these data are taken into account in real time, analyzing and comparing to the past when similar products have been made, whether the data looks similar or there are abnormalities that should be alerted. If there are abnormalities, then the alerts will be given, and those can be reacted to already before the end customer would receive a faulty product, which leads into better end customer satisfaction and higher efficiency in the mill, the sooner the problems are spotted in the production. Just a short pause in these cases. Let's have a look at the poll results. Which of the approaches to data utilization would your mill benefit most? So the 43% answered that predicting future events related to production. 21% was the getting big picture of what is happening and how variables are connected to each other. Then a tie of 14% was with automating manual tasks related to information handling, such as combining and pre-processing of data, and mill personnel getting information in the form of this might be interesting to you, as I talked about the recommendations. Thank you again for answering that, Paul. Let's continue with the manufacturing cases. This was for the quality assurance. Then the second one is proactive operations. The traditional way of handling things in many mills is we start from here. There's a problem and we need to fix that. First we'll start looking at what kind of data are we collecting, what data sources do we have that might have the answer. Then we start looking at what variables do we have in those data sources that might have the answer. And then we find out something and try to fix that and hope that it doesn't occur again. But this is usually a vicious circle of same kinds of problems occurring from time to time, and then solving those in a retrospective manner. Now, the kind of future way of doing things with smarter data utilization is having, and this is related to the predictions, analyzing in real time and in a predictive manner problems in the mill and kind of hints of abnormalities in all data that might tell you already before the actual economic loss is happening that these are the things that you should be looking at, or this kind of prediction is given that you will have this kind of quality problem or whatever it is. Now, when analyzing all data and giving alerts based on that, you are able to get early warnings and do proactive actions more and more compared to the past, resulting in being proactive and in that sense kind of saving money for the mill. And then the third one is troubleshooting. That was the retrospective way that we just talked about, but let's have a look at this in a more detail. Again, let's start from the fact that there is a problem in the mill. You start with one data source or several, and the expert in the mill then has a look at the problem, and let's say it's a quality problem, and the expert knows that in the past when we had this kind of a problem, the solution or the root cause was, let's say, in these 5 variables. So what you are actually doing is that you are just picking some variables of all that data there is possible to be utilized based on your past experiences as an expert. You get those variables to Excel or whatever the tool it is that you want to utilize, and you find out whether there is the root cause or not. If not, you go back, select some other variables, maybe from another data source, and try to work your way to finding out the root causes, fixing things, and hoping that that won't happen again. But usually this is very time consuming, and there might be acute problems, especially if the mill is not running or the production line is not running because of the problem. That will result in usually having some ad hoc solutions which are not sustainable and so the problems will happen again. The new way, which is utilizing artificial intelligence and machine learning especially, is to have the automated analysis utilize all data there is in the mill, analyze that, and give the expert a prioritized list of variables that might have might be the root causes for the problem. And then the expert can go through the kind of a short list of variables identified by automated analysis, and then pick the ones that are the answers to the problem that you have, and then fix them as soon as possible. So there are a few benefits here. You are utilizing all data there is and not constraining yourself to some small amount of data. And also the expert doesn't need to do the first steps, that you are automating many of the things, and then the expert can use their time to decide on what to do based on the refined information. Let's again have one more poll, and this is related to these different manufacturing cases that I talked to you about. Which of the presented mill data utilization cases would your mill or company benefit most? The data-driven quality assurance, the proactive operations, or automation-assisted troubleshooting, or something else? All right, those what we have covered so far is the data utilization, what it means, what artificial intelligence means for a manufacturing company. It's a lot about data utilization. Then we've covered how to approach data utilization in terms of first identifying the business problem, identifying the users, going to the actual user stories, what will the users do with the data and information. Then moving on to approaches, different approaches on data utilization. Then we went through these manufacturing cases, and now let's go to the last section, which is kind of the lessons learned that we have encountered with our journey with our customers on data utilization. Before going into that, let's have a look at the end results of the last poll. So which of the presented mill data utilization cases would your mill benefit most? There's a tie of 41% between data-driven quality assurance and automation-assisted troubleshooting. Then the proactive operations received 18%. Thank you very much for answering those polls. Okay, let's go to the lessons learned. These are derived from the pulp and paper industry cases that we have had, but I would say that all these are applicable to many other industries as well, especially when we're talking about process manufacturing. The first lesson to know for all of you is that do not overestimate the power of algorithms. Point is that algorithms or data quantity, there's plenty of data in typical pulp and paper mills, they do not always compensate for issues in data quality. And this means, in kind words, this means that if you put bad stuff in, you will get bad stuff out. Algorithms are not something that can automatically, in a magical way, transform something of bad quality data into something useful. And that's something that needs to be needs to be understood. Then do not underestimate the value of tacit knowledge in the mills, and don't outsource your thinking. And how to explain this is that sometimes we encounter companies or people who would say that it's good to have a machine learning or AI system in place here, so that they could even replace the people who are working here, as it will know everything, etc., etc. But the truth is that when starting implementing data analytics or AI or machine learning to a mill, the first results will most probably be useless, because to be honest, AI is usually dumb in a way that if it is put into the context that is not familiar to it, then it will find out things that are self-evident for the people who know the context, who have been working there for 10 or 20 years already. The point being is that the first results of machine learning, for example, need feedback from the domain experts who understand the context, the mill, the data there, because statistically some things might be abnormalities or very interesting for an AI, but they might be something completely useless for the people who understand the context of the data. So that's why it might take years before, or I would say decades before we would arrive to the point that we would have AI solutions that understand fully the context. What AI is really good at compared to humans is automated analysis of all data, kind of seeing the interlinkages and so on. But the context is something that is many times missing at first, at least. And that's why tacit knowledge from the mills is very important to be participated in the projects in the first place, and also to kind of co-work with the AI to do things better in the mill. Then the third thing is try many things. Start small and scale big. Do not, as your first project in data utilization or AI in a mill, don't plan to have a kind of a overall mill all problem solving solution. Instead, start small and expand from there, kind of in a lean way. Then if the data is not adequate for one thing, it might still be very suitable for other things. This meaning that if you're starting your first AI project and you're selecting one business problem, and you select some data for that, and start working with that with a supplier or on your own. If the first results from let's say a proof of concept or a pilot project are bad, that might not be the case. That the conclusion should not be that everything that you could do regarding data utilization in the mill will be bad. It might just be that that data was not suitable to answer that kind of a problem, but that data might bring you a lot of answers to some other problems, or then the problem itself could be answered by looking at some other data sources as well. Then fourth one is measure what you want to optimize, and This is related to the first bullet. So the comprehensive data combined with analytics brings the best results. It is not in the way that analytics again could bring you very good results if you don't have data in the first place or your data is of bad quality. So it's always a combination of all these different aspects regarding what data do you have, who is utilizing that, what analytics can done in the middle to kind of close the gap between raw data from sensors or quality measurements to useful information in real time for relevant people in the mill. And the last one is that there are many ways to utilize data, and it is not technology but imagination and sometimes data that constrains us. So that needs to be kept in mind. And I hope that the approaches that I talked to you about today on data utilization give you, and the cases as well, give you some ideas on how you could move further in terms of data utilization and ultimately leading into better operations in your mill. And lastly, kind of a brief sales pitch is that one of the lessons learned, of course, is that we have been developing our product for many years now, especially working well in the pulp and paper industry, but also in other process manufacturing environments. And what we have noticed is that there are certain things that are similar to all mills, and some other things are different. And one of the key challenges for us was to really try to tackle those problems that are general in many different mills, and then still have the flexibility of doing custom things to the product, as every mill is somewhat different from another. So this is our Quva Flow software, which is enabling more stable production. And in brief, it's about combining different data sources in the mill, configuring the analytics engine to bring out the meaningful information automatically, and visualizing the information in the form which is easily approachable for the end users, and the users can be of different experience and background or roles, like operators, process engineers, quality engineers, and managers. So that's what we are doing. And I'd like to end the presentation and the webinar by letting you know that if you're interested to hear more about our product, you could book a 30-minute demo by either emailing or calling me. You can see my contact details there. And let's have a Skype or a live meeting, and I can go through how we are tackling these things on identifying abnormalities in data in proactive way, automating troubleshooting, etc. And then lastly, the next webinar would be in Q2. I will send a newsletter about that later, on continuous improvement 4.0 and how we can help you do that better. So thank you very much for your time and joining the webinar. I hope you have learned something here, and